Hi everyone, welcome back to Chemical Engineering Statistics. So, when comparing two samples, sometimes we don't know the distribution of sigma 1 square and sigma 2 square. If the sample size is N1 and N2 is more than 30 or can be categorized as large sample, the normal distribution procedure in the previous video can be used. However, when the sample number is small or is less than 30, we can assume that the population are normally distributed and base our hypothesis test on the T distribution. In two independent samples with unknown populations variance and small sample, we might have two cases. In the first case, we can assume that the standard deviation or the variance of the first population is equal to the standard deviation or variance of the second samples. Here we can see that sigma A equal to sigma B. In the second case, we can assume that sigma A is not equal to sigma B. To determine the equality of the standard deviation or the variance of two samples, we need to do an F-test. We will discuss about F-test later on. So if we look at this slide, we already have the test statistics and all the equation to do the hypothesis testing of these two independent samples with unknown population variance and small sample. X is the random sample. X bar is the sample mean. S is the sample variance. So S1 is the sample variance of the first samples and S2 is the sample variance of the second sample. We also have V on the right bottom equation. V is the degree of freedom. Other variable is SP square. SP square is the pooled estimator of sigma square. This is the combination of two sample variances, S1 square and S2 square. So please look carefully at the equation and choose which equation should be used to solve your case. For example, here we have two types of catalysts. Catalyst 1 is currently in use and Catalyst 2 is acceptable and cheaper. So we conduct a test in a pilot plant and the data is shown here. So this data show the mean yield of a chemical process conducted using the catalyst. What we want to know is there any difference between the mean yield when we use catalyst 1 and when we use catalyst 2? Here, because we haven't studied about the F-test, we can assume equal variance. So we go for case 1 calculation. So the parameter of interest in this case is the difference between the mean yield of the chemical process. So we want to know whether the mu1 minus mu2 equal to 0. Mu1 minus mu2 equal to 0 indicates that both catalysts result on the same performance. So the null hypothesis is mu1 minus mu2 equal to 0. The alternative hypothesis is mu1 is not equal to mu2. We can calculate the T0 using the test statistics equation, and we can reject the null hypothesis if the p-value is less than 0.05. 0.05 is our so 0.05 is 1 minus our confidence limit. So after do the calculation, we can draw the conclusion by using the p-value approach or by comparing the T0, the test statistics, with the critical T obtained from the T-table at respective degree of freedom. So that's all for now. See you in the next video.